Okay, so last time we left off, we were talking about piecewise functions, and we went through an example, and we just kind of started on a new example, and that's where we'll pick up today. So we want to try to graph this piecewise function and write its domain and range. Okay. All right. So first things first here. I want to know if we divide this up into pieces, first of all. Okay, that's useful to do. So then we'll color code this so we know which one we're talking about easily. How many pieces are there in this piecewise function? Just show me fingers or type it in chat. How many pieces are there in this piecewise function here in this example? Okay, I should be hearing from everybody. Okay, good. There are 3, aren't there? Okay, very good. Oops. Okay. All right, so let's color code these. Let's make the first piece, top piece, we'll make that red. So there's our red piece. Here's our blue piece. We'll make this bottom one our green piece. How about? The blue piece is the function 2x, and its domain is x is less than or equal to -2. So the red piece only gets graphed or only exists for x values less than or equal to -2. The middle piece, the blue piece, is the function -1 minus x, and its domain is x is greater than -2 and less than 4. What's the boundary value of x between the red and the blue pieces? What's going to be the boundary? What x value is the boundary between the red and the blue? Everybody just type it in chat or hold up fingers. What's the boundary there? If an ant were walking along this function from left to right, the ant's going to be transitioning from the red to the blue to the green, right? During his journey. So the ant is walking on the red piece. If he starts at -infinity, it's a long trip. He's walking to the right. Well, he stays on that red piece until he gets to what x value? Everybody type it in if you got an answer. He stays on the red piece until he gets to what x value? Okay, I'm starting to see some -2s here. That's good, right? At -2. At -2 is when he's going to make a transition. When x gets to -2, that's the end of the red domain, and that's the start of the blue domain. Okay, so I'm going to want to have a boundary there, aren't I? I'm going to want to put a vertical line that acts as a boundary, and that vertical line is going to be at -2. Okay, so let's write that down. We've got our vertical boundary line between the red and the blue is at x equals -2. Okay, where's the boundary value of x going to be between the blue and the green? The ant's going to stay on that blue. He's going to start on the blue when he gets to -2, right? As he moves to the right, he stays on the blue until he hits what x value? Type it in chat. Okay. till he gets to 4. That's correct, right? Till he gets to 4. So there's going to be another boundary right there. So those are our boundaries, right? We could say then that the red region is going to be the region to the left of x equals -2. That whole infinite region, that's where the red graph is going to have to sit, isn't it? And the blue region is going to be the region in between that sits on the blue domain, and the green region is going to be the region at the right. So there are our two boundary lines. That's the red region. Agreed? Okay, let me do one thing here real quick. This is going to be helpful if I... There we go. That'll be helpful. Okay, so let's go ahead and let's use our T-table technique that we talked about a couple days ago. And let's graph the piecewise function. Let's just take the piece of the piecewise function that's on the red domain. Now, I want you to make a prediction for me. Describe what the red piece of the function is going to look like. And be very specific. Think back to your geometry class. Is it going to be a line or a line segment or a ray? What's it going to be? Type it in chat. Think back to geometry. Let's do just a 10-second review of what those things are, right? So we know what a line is. We deal with lines all the time. Lines go forever in both directions, right? Okay, we know what a line segment is too. That makes sense. A line segment is going to be a piece of a line that's got endpoints at both ends of the segment, right? Now, what's a ray? Describe a ray for me. Lexi, what's a ray?
Isn't a ray with like a solid side on one side and an arrow on the other?
There you go. Okay, good. So it's going to have an endpoint, isn't it? It's got one endpoint, and then it's going to go forever in some direction. If I wanted to graph a ray, think how you did that in geometry. You had to find the endpoint, and then you had to find some other point out there that the ray went through so we could give it a direction, right? Now, which one of those three things is going to happen in the red region? If I graph the function 2x, which is the equation of a line, but I'm graphing that line in the red region, what's that going to give me? Once again, type it in chat. I'm only hearing from one person. Need to hear from everybody. Okay, I got a couple people contributing there. Does that make sense? So they're making a suggestion that's correct. Yeah, it's going to be a ray, isn't it? Right? Because it's going to be a line, but the line's going to stop when it gets to the endpoint, which means when it gets to the boundary, which means it's going to have an endpoint there. It's going to turn it into a ray. So if I want to graph a ray, let's think about that strategically. Well, if I'm graphing a ray, we said that we wanted to know, first of all, what's the endpoint? What x value am I going to plug in to my red piece to determine the ordered pair for the endpoint? What's the x value at the endpoint, in other words? Type it in chat. Okay, boy, I'm not getting everybody involved in this. If your cameras are off, I better be seeing lots of quick responses from you. Okay, good. I'm seeing lots of -2s. Good. I could plug -2 in. If I plug -2 in for x, I'm going to get 2 times -2 is -4. And remember, one of the really nice things about these t-tables is each row in a t-table corresponds to an ordered pair, right? So we've got the ordered pair, -2, -4. Okay, is that going to be a solid or an open endpoint? Solid or open endpoint? Devin Driscoll.
I think it will be solid.
It will, because the red domain includes the x value -2, right? So we're going to have a solid endpoint at the coordinates -2, -4 in the xy plane. There we go. Okay, very good. Okay, now for the other point, I just need some point to the left of that. It doesn't matter what x value I pick. Let's just say -4, how about? 2 times -4 is -8, and so I get another point at -4, -8, which is right there. And now all I've got to do is create a ray from those 2 points. Okay, and there we go. I'm going to start at my endpoint and just go through the other point to create my ray. And there it is, right? There's my ray. Give it an arrow because it goes forever to the left. Okay? All right, let's move on to the next region then. We got the blue region. That's going to be the interval of x values between -2 and 4. So there's my blue region. What's going to be, if you look at the blue piece, if I write this in slope-intercept form, it's just the line y equals -1x minus 1. So it's got a slope of -1 and a y-intercept of -1. We don't necessarily care about that stuff, but it tells me that I've got some slanted line that we're only going to capture the piece of that line that's in the blue region. So what is the blue piece of this piecewise function going to look like? Which geometric object is it going to end up being? Madeline?
Would it be a line segment?
Yeah, it's going to be a line segment, isn't it? Right, in a line segment, really to draw a line segment, I just need to figure out what are the endpoints and then connect them. So what's the first x value I should probably plug in to my blue piece of the function? Madeline?
-2.
Yeah, -2. Good. Because that's going to be the boundary, isn't it? So if I plug -2 in, I get -1 minus -2 is like adding 2. So I get the point -2, 1. Okay, now, Madeline, is this going to be an open or a closed endpoint?
Open.
Yeah, good. It's going to be open, isn't it? Because we know that our blue region does not include the x value -2, does it? Okay, so I'll do one thing here. There we go. Okay. Go away. Come on. There we go. Okay, so we get 1 point, an open endpoint at -2, +1. So there it is. Okay. And then the other point I would pick would be at x equals 4, isn't it? So if I plug 4 in, I get -1 minus 4 is -5. So I'm going to get another open endpoint because x does not, we're not including the x value of 4 either in the blue domain. So I get another open endpoint at +4, -5. So right there. And then all I got to do is just connect those endpoints, right? So there we go. Everybody agree that's the blue piece of the function, piecewise function? Give me a 1 to 5, everybody, real quick. Okay. Okay, any questions? People asked some questions second period, and that was so helpful. If you're not at a 4 or a 5 on this, is there a question you can ask me that can clarify something for you and everybody else? Be brave.
Yeah, I got a question.
Sure.
How did you get the X values?
How did I get my X values?
Yeah.
Okay, because because we know that we're going to get a segment, right? And we said when we did our little 10-second geometry review, a line segment is just a piece of a line that connects the two endpoints. So we want to pick the X values of the endpoints ideally. Do we have to do that? Well, no, I guess we wouldn't have to, but it's really convenient because then we know the exact locations where the segment ends on both ends, right? So where it meets the boundaries. How do we know what those values are? Well, they're going to be -2 and +4 because those are the edges of the blue domain. Okay, does that make sense?
Yeah.
Okay. Any other questions? Okay, we'll try again here in a little bit. Let's do the last part of this. So then the green region, that's going to be the graph where we're going to graph the function y equals -3 or f of x equals -3 for x values greater than or equal to 4. So that means to the right of our boundary at x equals 4. So it's going to be over there, isn't it? That's going to be our green region. It just extends forever to the right. So what would be the most logical value of x to pick first here? Jaden, what do you think? Because I'm going to get a ray, aren't I? Okay, let's try Delaney Coiner. What value of x should I plug into the green piece here, first of all?
4.
4, exactly, 4, because that's going to be the endpoint, right? So we'll plug 4 in. Well, there's nothing to plug in. Look, here we've got the function f of x equals -3. So regardless of what x value you plug in, what's the output always going to be, Delaney?
-3.
There you go. So if I plug in 4, I get back a -3, right? So that means I'm going to have an endpoint. It's going to be solid because the green domain includes, I have an equal sign on my inequality. I'm including 4. So I go over 4 and down 3, and there's the left endpoint of my ray that I'm going to end up building, right? Okay, I could pick any value of x to the right, and it doesn't matter because we know the output's going to be -3 every time, right? So I'm going to pick 8. If I let x equal 8, I already know y is going to equal -3. So if I go over from the origin, I go over 8 and down 3. Well, there's my other point that defines my ray, and now I can build my ray. All I'm going to do here is I'm just going to start at my endpoint. Oops, let's do that again. Start at my endpoint and go through that other point and then just on forever to the right. So there's my ray. Everybody give me a 1 to 5 on the graph. Okay. Questions? Muriel, can you think of a question that you could ask that might help?
For me, it's confusing because you use a lot of colors, and like on ours, like you necessarily can't get a lot of colors because it will just like play through it. That's just confusing for me. And also, how are you getting like your x and y? Are you just like plugging in a calculator to get your?
Well,
point?
I mean, I could, but I'm just using the function over here to get my y values, right? So my x values, my x values, I'm choosing. Well, like for example, for the green one, I chose the x value 4 because that's at the boundary, and then the other x value I chose just because it's some value to the right of 4. So x is greater than 4. What about the blue? I chose the x values -2 because that's my left boundary, and +4 because that's my right boundary. How do I get the y values? I'm just plugging them into the function. So when I'm on the blue piece, I'm using the function f of x equals -1 minus x, right? So if I plug in -2, I get -1 minus -2, which gives me +1. So that's my output. When I plug in 4, I get -1 minus 4 gives me my -5 y value. Okay, does that make sense?
Yeah, so pretty much how you get your x values by the boundaries.
Right, the boundaries. And then like for the red one, I picked my first x value was at -2 because that's on the boundary. And then the other one, I just needed to pick there is no boundary to the left, so I just needed to pick some other x value to the left of -2 so I could have 2 points to connect and extend. Okay, does that make sense?
Yeah.
Okay, and as for like the shading is that really important? No, it's not really important. It's just a way for us to make a visual connection when you look at your notes here between I've got this red piece of the function and there's the red part of the graph, right? There's a blue piece and there's the blue part of the graph. Are you going to have to do that when you make yours? No, of course not, right? That's just there when we're going through this stuff, so it's easy for us to make those connections. Everybody see that, how that works? Okay. All right, so we're not quite done though. We got to get the domain and the range out of this also. We talked the other day about the domain and the range as being the projections of the function onto the x-axis and the y-axis, right? Because the domain is the set of all the x values on the function, correct? Okay, so let's take all three pieces of this, the red, the blue, and the green, and let's project those onto the x-axis to give us a graph of the domain of all the x values that are contained. And let's make that, how about we'll make it orange? So the domain we're going to make orange. If I take the x values from the red function, well, the biggest x value is -2, and then the x values for the rest of that just go forever in the negative direction, right? Because we could walk, an ant could walk along the red piece forever to the left. He'd be going down, but he'd also be going to the left the whole time. So if I project those up onto the x-axis, what happens? Well, if I project this point up onto the x-axis, it's going to end up being right there. And then all these other points are going to project vertically, and they're just going to give us that for the domain of the red piece of the function. Everybody see that? It's going to include all the x values less than or equal to -2. Okay, what about the domain of the blue region, the blue piece of the function? Well, I would project this open endpoint straight down, and I would get an open endpoint there. I would include all of the x values in between, and I'd have an open endpoint down here at the other edge where I project this point up to the x-axis. Okay, so there's where we are so far. What about the green one? If I project the green graph up onto the x-axis, well, this closed endpoint here is going to go up and fill in the open endpoint, and then all these other points are just going to extend, their x values extend to the right. And so look at that. I end up with every place on the x-axis ends up being filled in, right, by our projections. And so our domain is just all real numbers, -infinity to infinity. Okay, everybody give me a 1 to 5 on that concept. Okay, let's get some questions on this one then. Give me some questions that'll help you understand. Because if you ask a question, if you're brave and ask a question, there are a lot of people are saying, oh man, I'm so glad they asked that because I had the same question. It's going to help everybody.
So it might not pertain to this question, but
Mhm.
like, what if one of the dots was open and so like there's like a gap in the line? How would you write the domain of that?
Okay, that could happen. Then if there were an open dot there, like let's just say hypothetically, and I'm going to erase this in a second, so don't let this confuse you. But what if we ended up with an open dot there, an open endpoint, then how would we write that? Well, we'd have to do that in two pieces, right? We'd have to say something like the domain goes from negative infinity up to -2, then we put a comma, or it goes from -2 to infinity. So we skipped the -2. See how that works?
Yes.
Okay, good question. Very good question. Okay, let me get rid of that stuff. Come on. There we go. Okay, other questions? Okay, let's try the range. Maybe we get some questions from the range. So now for the range, we're just going to project all pieces of the function onto the y-axis this time. So let's make the range, let's make that purple so we can distinguish between the two. So the red piece, if I project that onto the y-axis, that point's going to get projected over onto the y-axis and end up right there. And then the rest of all these infinite points are just going to go down to negative infinity on the y-axis. So there's the projection of the red range. What about the blue range? Well, the blue range, we're going to have this upper endpoint right here that's going to be open, right? Because that's an open endpoint. And then over here, this one's going to project over, and it's going to be open, but that's already filled in, right? That's filled in anyway because that's already a part of the red range. And then all the y values in between would get filled in. Okay, so it would end up looking like that, right? And remember, this one is actually, it was an open endpoint that was already over a point that was filled in, so we'll just make it closed. And then finally, what about the green graph? If I were going to project that over onto the y-axis, well, look, all these points end up getting smushed together at the same place, don't they? Because they all have the same y value. And so the entire projection of the green piece ends up being just a single point right there. Okay, so what's the result then? Well, we have an open endpoint at the top and every other y value is filled in below that. So my range then, the lower limit is going to be at negative infinity. The upper limit is at +1. And I'm going to have to put parentheses there because it's an open endpoint. Okay, give me a 1 to 5 on that. Okay, can somebody ask a question to help clarify?
So with the green line, because it's like horizontal, it makes a dot, but if it was pointing vertical or more vertical, upward, would it be a straight line up?
Yes, it would, right? So here's the what if question on this one. What if the green part looked like this? What if it looked instead, like what if it had an endpoint here and it went up like that? Then it would have, in that case, it would have a solid endpoint down here and it would just go up, it would just go up forever, right? The y values would climb forever and then it would have covered the entire y-axis. Okay, if that had happened. Good question. Okay, any other questions? All right, let's do another one. Okay, how about one like this? We got 3 pieces this time. Everybody agree? Where are the boundary line, or where are the boundary values of x going to be? Where do I need to partition this thing? I need to draw my vertical boundary lines in at what x values? Carson, give me one of them. Questions for Carson? Okay, how about Olivia? Where would my boundaries be? What x values?
0 and 6.
Yeah, 0 and 6. Everybody see that? Because look, I've got a 0 right there. That's where the top piece leaves off and the next piece starts. And then I've got a 6, which where the middle piece stops and the bottom piece starts, right? And so I could color code these things like always, just to kind of separate them. So let's call the top one the red piece, middle blue, bottom green, just like before. And we've got these regions then, right? The red region, the red domain extends to the left of our boundary line at 0. The blue domain, which defines the blue region, is between 0 and 6. And the green region, so the green domain, is for values greater than 6. Now, all I've got to do is just graph the pieces in those regions to get the graph. Okay, so in the red region, give me a thumbs up, thumbs down, thumbs sideways here. So yes, no, or maybe if you're typing it in. So does it make sense to everybody here that I'm going to get a ray in the red region? Okay, give me thumbs up, thumbs down, or yes, no, maybe in chat. I want to see if get feedback from everybody. Olivia, do yours again. What was yours? Okay. Can you ask a question about that, Olivia?
Yeah, so the ray is a horizontal line, right?
No, it doesn't have to be horizontal. It can it can point in any direction, but it's just got an end point and it goes forever.
Okay, so it has either an open or closed spot and then it goes on forever.
Yes, it goes on forever, right? It's going to go on. It's going to have an end point at x equals 0, isn't it?
Yes.
And then it's going to go forever. It's going to be slanted, but it's going to move to the left and be slanted, right?
Okay.
Does that make sense?
Yeah, because it's negative.
It's negative, so it's going to slant. So it's a negative 3x. So if the slope is negative, it's going to end up looking kind of like that, isn't it? And have an endpoint. It's going to be moving down from left to right and bump into the boundary and form an endpoint. Okay.
Yeah, that makes sense.
Okay. So to graph the ray, we just need 2 points. We need the terminal point or the endpoint, which is going to be at x equals 0, right? So we want to plug 0 in. Well, negative 3 times 0 is just 0. So we get the ordered pair 0, 0. So we know right away here then that, let me move these guys. There we go. Okay, so we're going to get an endpoint at 0, 0. Olivia, is that going to be an open or a closed endpoint?
Open.
It's going to be open. Good. Right? We know that's going to be open. Okay. Go away. There we go. Okay, so we get an open endpoint at, I picked the wrong one, didn't I? I want to pick this one. That's the one I want. So we get an open endpoint at 0, 0, so it's right there. Okay. Now we need another point somewhere to the left of that. Doesn't matter. Doesn't matter what x value you pick, just an x value less than 0. So I picked negative 2. Negative 3 times negative 2 is 6. So I get another point at negative 2, negative 6. So I go back to, or negative 2, positive 6, sorry. Go back to, I go up 6. And that's all I need to graph my ray. So I start at my endpoint at the boundary, and I'm just going to go up through that point forever. Like that. Okay, everybody give me 1 to 5. Okay, good. So now, what's going to be the shape of the blue piece this time? What's the shape of the blue piece going to be, Nettie? Ray, segment, or line?
A segment.
Segment, very good. And what are the x values I should plug in?
6 and is it 0 and 6?
There you go, 0 and 6. Very good. So if I plug 0 in, I'm going to get negative 1/2 times 0 is 0, minus 1 is negative 1. So I get the point 0, negative 1. Solid or open on that one, Nettie? When I plug 0 in.
Solid.
Solid, good, because it includes, we have an equal sign, it includes 0, doesn't it? So 0, negative 1 puts us right there. And then you told me to plug in 6. Negative 1/2 times 6 is negative 3, minus 1 is negative 4, right? So now we want to plug in an open endpoint, correct? Because I'm not including the 6. So let me do this. Oops. Oh, there we go. Okay. So there we go. Okay, so that one's going at 6, negative 4, so right there. And then all I got to do is just connect those with a segment. There it is. So there's my blue piece. Everybody good? Okay, what about the green piece? What am I going to plug in? Aiden McDermott, what X value am I going to get a ray, a segment, or a line for my green piece of the piecewise function? It's going to be a ray. Good. Okay. So what's the X value of the endpoint of my ray? 6. Good. So I'd plug in a 6. And 6 minus 7, if I plug it into the green piece, I plug in 6 for X. I get 6 minus 7 is negative 1. So I've got an open or closed endpoint. Which one's it going to be? It's going to be open. Good, because the green domain does not include, come on there. Green domain does not include the endpoint, right? So I need an open endpoint. I got to build one here. There we go. So over 6 from the origin, down 1. There it is. And now, Aiden, what's another value I could pick for an X value to get another point so I can graph my ray? I need another X value that's in the green domain, which is all X values greater than 6. So there's no right or wrong answer on this one. 8 would work, sure. Let's pick 8. So if I pick 8, I get 8 minus 7 is 1. I could have picked 7. I could have picked 9. 8's a good one, though. So now I get a point over 8 and up 1. And now all I got to do is build my ray by connecting. There it is. Okay, so there's my graph. Now let's get the domain and the range out of this, right? Okay, so what about the domain? Let's make the domain orange, just like before.
Mr. Oreo, would it be a open endpoint on the 8.1 because it's not a greater than greater than or equal to sign?
Okay, but you're right. No, you're right. It's not greater than or equal to, but only the 6 would be open because think of all the X values that are included in the green domain. It's every X value greater than 6 would be solid because those are included. Only the endpoints could ever be open. See what I'm saying? Okay. All right. So now what about the domain? Domain's going to be orange. So let's do the red projection first. If I project the red graph onto the x-axis, would everybody agree? Well, look, this point's already on the x-axis. So we already have an open endpoint at the origin, and then all of these other points here are just going to project down. I'm going to smush them down vertically onto the x-axis, and it's just going to create an infinite number of points that go on to the left forever. Okay, so there's the graph of the red domain. Give me 1 to 5 on that, everybody. Okay, what about the blue domain? Well, if I've got a solid blue endpoint, if I push that one up, it's going to give me a solid endpoint at 0, which is going to fill in that open endpoint. And then over here at the other end, I've got an open endpoint that's going to get pushed all the way up, and it's going to give me an open endpoint at the right of my domain, and everything in between gets filled in, right? So there's the red and the blue combined. Now let's add the green to the mix. Well, look what happens here. This is exactly the situation that Noah was asking about earlier, right? Because look, I've got 2 open endpoints at 6. There is no closed endpoint. And so when I push that green endpoint up there, it stays an open endpoint, and then all the other x values to the right of that endpoint are going to fill in the rest of the x-axis. So the entire x-axis is filled in, except I've got that one open point, right? So how am I going to say the domain then? I've got all those points except one. How could I say that, Jonathan? What's my domain going to be?
It would be parentheses, negative infinity, parentheses 6.
Okay, comma. And then what?
And then parentheses 6, comma, and then infinity.
Good. Okay, so the one value that got skipped there was 6, right? There is another way we could say that. Sometimes we just say, okay, well, if it's everything except 6, the other way we could say the domain would just be to say x is not equal to 6. And that implies that everything else works, but just not 6. Okay, but if we're using interval notation, we'd have to do it like this. Okay, what about the range? Let's finish up the range and then we're good for today. So we'll make the range purple. So if I want to do the projection of the red graph onto the y-axis, well, I've got a closed, actually that was an open endpoint originally, wasn't it, for the red one? Yeah, it was. Okay, so let me go back. Right, remember that our red graph did not include 0. So I'm going to have an open endpoint, and then all of these other little pieces up here, as this graph moves up, each of these other infinite points is going to project over, and they're just going to give me all the values of y going up to infinity from 0, right? Okay, what about the blue? If I project the blue over onto the y-axis, well, this point is already there, isn't it? So I've got a solid endpoint to my blue domain. The other blue endpoint, if I project it onto the y-axis, it gives me an open endpoint right there, and then all of the other y values in between would get filled in. Okay, what about the green range? Okay, I've got an open endpoint that gets projected over, and look, that one's already filled in. And then every other value of y above that is going to be included. So I would graph all of this stuff up here that's already graphed. So it fills in that open point there, doesn't it? Okay, so what do we end up with then? We got an open endpoint at the bottom, and it looks like every other point to infinity is filled in. So how am I going to say that one Let's see. Muriel, how am I going to say that one? How am I going to say the range here then? I'm looking at the y values now.
Want to be like -4 and infinity.
Okay, -4 and infinity. What am I going to put to the left of the -4? A bracket or parentheses?
Parentheses.
Yes, parentheses, because it's an open endpoint. And then it goes up to infinity. Very good. Okay. All right. That's it. There's more examples we can look at. You know, this one's taken a few days, and I get it. I mean, it always does. The piecewise functions piece is there's a lot going on there. Okay, we're going to look at just a couple little other parts of this. And so I'll push the assignment off a little bit. I'll push it off until next week because obviously you're going to need a little time on this one. We'll wrap it up though next time and probably start the next section too. Okay, any questions? All right, hey, good job today. The questions really helped me. I'm going to let you go 2 minutes early. Start your lunch 2 minutes early. I'll be here during office hours if you need me. Have a great day.